Most organizations think more apps means more productivity. They're wrong. More apps means more governance surface area, more connectors, more owners, more permissions, more places for data to leak, and more tickets when something breaks. The thesis is simple. Governance by humans doesn't scale. Control planes scale trust. Today, this is a single operating model shift from building apps to engineering control planes that reliably cuts governance-related support tickets by around 40%. If that's the kind of thinking you want, subscribe. This channel does control, not crafts. Now to the autopsy. The foundational misunderstanding. An app is the solution. The foundational misunderstanding is that an app is the solution. It is not. An app is the user interface veneer over a chain of identity decisions, connector pathways, environment boundaries, and lifecycle events. And the weird part is, the most expensive parts of that chain aren't visible in the Maker Studio. They show up later in audit evidence requests, incident bridges, and the support queue nobody can empty. Here's why this misunderstanding persists. App-first incentives reward shipping something that works once, for a single team, under a single owner, in a single moment of organizational stability. The moment you demo it, it's done. The moment you release it, the organization treats it like infrastructure. But the build model doesn't treat it like infrastructure. It treats it like a document, editable forever, shared loosely, and dependent on tribal knowledge to stay alive. That distinction matters. Because governance and risk don't live inside the app canvas. They live in the control plane. Entra principles, conditional access evaluation, connector permissions, DLP boundaries, environment strategy, and the inventory that tells you what exists. When you build apps without engineering that layer, you're not delivering productivity, you're exporting responsibility into the future. And executives unknowingly fund this. They think they bought a workflow. What they actually funded is a new branch in the authorization graph with connectors that create data pathways, with owners that can leave the company, with credentials that expire, and with policies that will drift because nobody wired the drift detection. That's not cynical, that's the platform behaving exactly as designed. Now, the part architects keep missing, app-first governance turns deterministic systems into probabilistic ones. A deterministic security model says, these identities can access these resources under these conditions, and that statement stays true tomorrow. A probabilistic model says it depends on which exception applies, which connector got added, which environment a maker used, which label got applied, and whether the owner is still employed. Over time, exceptions multiply outcomes. The organization becomes unable to predict what will happen when a user clicks run. Conditional access is a great example because it's literally a policy engine that evaluates signals and applies controls. But it's additive. Policies stack, exclusions stack, overlaps stack. People don't build a single coherent policy set. They build a pile of fixes. And that pile becomes what many practitioners call conditional chaos. Not because conditional access is bad, but because humans use it as a patch panel instead of a compiler. So when someone says, we'll govern it with an approval board, what they're actually saying is, we'll turn system behavior into meeting behavior. Manual review queues become the throughput limiter. Every exception approved becomes precedent, and then the board is no longer enforcing policy. It's negotiating entropy. This gets worse with Copilot and agents because the number of runtime decisions explodes. A classic app does what you programmed. An agent does what you allowed based on a prompt, grounded in data, using tools in a context that changes per request. That doesn't make agents evil. It makes them probabilistic. And probabilistic systems demand control planes, not best effort documentation. Microsoft's own ecosystem already assumes control planes exist. Entra is a distributed decision engine. Microsoft Graph is the unified plumbing for lifecycle and configuration at scale. Purview DLP is a policy enforcement layer. Power Platform admin features exist specifically because app first doesn't scale. But in most tenants, those are treated as optional admin chores. The organization ships apps, then asks admins to clean up later. That is architectural time travel. You can't retroactively add determinism to a system that already shipped 1,000 unique variations. Here's a simple operational test. Ask, if the original maker quits today, can this app be safely maintained, audited, and retired without heroics? If the answer is no, you didn't build a solution. You built a hostage situation with a nice UI. Control planes fix this by moving decisions upstream. They don't make makers slower. They remove the need for humans to be the policy enforcement mechanism. They convert governance from review into design. Identity, provisioning, and DLP become default rails, not after-the-fact policing. And yes, that feels like an operating model shift because it is. You stop counting apps. You start engineering the system that creates apps safely, consistently, and with an end of life by default. Now that the disease is defined, the next step is uncomfortable. Look at your app estate the way an incident responder would, not the way a maker would. App sprawl autopsy, symptoms you can't ignore. App sprawl isn't a vibe, it's observable system behavior. And it shows up the same way in almost every tenant that scaled Power Platform and M365. Without an engineered operating model, the estate grows faster than the organization's ability to explain it. not govern it, explain it. The first symptom is the 3000 plus app pattern. The number doesn't matter, the shape does. Once you cross a certain threshold, nobody can answer basic questions without an excavation. What does this app do? Who depends on it? What data does it touch? And what breaks if it disappears? At small scale, you can fake that answer with tribal knowledge. At enterprise scale, tribal knowledge becomes a single point of failure with a resignation letter. So the estate becomes a museum of half-finished ideas. Temporary apps that became permanent. Pilot flows that now run payroll-adjacent logic, and approvals built by someone who moved on 2 reorganizations ago. Everything still works until it doesn't. That's the trick. Sprawl stays quiet right up until the day it becomes your incident. The second symptom is orphaned ownership. This is the most boring, most lethal failure mode in low-code environments. Makers leave, contractors rotate, people change roles. The app and flow don't leave with them. The ownership does, and then simple maintenance actions, updating a broken connection, changing a variable, rotating a secret, fixing a connector deprecation, suddenly require admin intervention because nobody has the rights to touch the thing that runs a business process. In unmanaged estates, this is where admins become human control planes. They don't design the system, they patch the outcomes. They get pulled into every broken flow, every failed connection, every can you just request that should have been an automated lifecycle rule. Over time, support turns into archaeology, digging through dead assets to find the one piece of logic that still matters. The third symptom is default environment gravity. The default environment is supposed to be a convenience. In practice, it becomes a landfill because it has the lowest friction and the least accountability. Makers build there because it's available. Teams share there because it's easy. And the moment something in the default environment delivers value, it becomes politically difficult to move because moving implies admitting it was production all along. So the default environment becomes a production environment that nobody is allowed to call production. That's not just messy. It breaks every governance assumption you think you have. Environment boundaries, DLP segmentation, solution lifecycle, and basic separation between exploration and regulated workloads. The fourth symptom is connector creep. Every connector is a data pathway. That means every connector is also a policy obligation. Logging, review, data classification, and in some cases licensing and vendor risk. But in app-first cultures, connectors don't feel like pathways. They feel like buttons. So they accumulate quietly. One flow uses a consumer connector for convenience, another app uses a premium connector because it was faster, and suddenly sensitive data has multiple exits you didn't design. The platform didn't betray you. It did exactly what you configured. You just didn't treat connectors as part of the architecture. And when DLP feels inconsistent, it's usually not because DLP is random, it's because your environment strategy is random. Tenant-wide policy meets environment-level exceptions, meets temporary maker sandboxes that turned into operational dependencies. The enforcement looks inconsistent because the estate is inconsistent. The fifth symptom is that support tickets become the leading indicator. Not because support is incompetent, because tickets measure friction. They measure ambiguity, they measure missing ownership, missing inventory, and missing boundaries. A governance-related ticket is rarely, the app is broken. It's who owns this? Why can't I access that? This connector stopped working. DLP blocked my flow. The environment is full. The service principal expired. The approval is stuck. Copilot did something we can't explain. Tickets are the tenant telling you the control plane is missing. Here's the uncomfortable autopsy conclusion. App sprawl isn't caused by too many makers. It's caused by too few enforced assumptions. When governance depends on humans reviewing outputs, the system scales by creating more outputs. Therefore, the organization hires more reviewers. That's not governance. That's an entropy payroll. The next step is to stop treating these symptoms as separate problems. They share a single root cause. Governance that depends on human review as the enforcement mechanism. Root cause governance that depends on human review. The root cause behind app sprawl isn't that people build too much. It's that the tenant's safety model depends on humans catching mistakes after the fact. That model always collapses because human review is the slowest component in the system. And in distributed systems, the slowest component defines throughput. Not the best intentions, not the policy document. Throughput. So the organization creates a queue, a board, a mailbox, a form, a process. Then every new app, flow, connector request, environment request, and DLP exception becomes an item in that queue. The makers don't stop building. They just keep building until they hit the queue. And once they hit the queue, they do what humans always do when constrained by a bottleneck. They route around it. They build in the default environment. They reuse someone else's connection. They temporarily use a personal connector. They ship without review because the business deadline is real and the governance deadline is a suggestion. This is the uncomfortable truth. Governance that requires a review step trains the organization to avoid governance because the system rewards output, not operability. Now, this is where approval boards become entropy generators. On day 1, the board exists to protect the tenant. On day 90, the board exists to keep the business from yelling at IT. The board starts approving exceptions just this once because the request sounds reasonable in isolation. But exceptions don't stay isolated. They accumulate, they get copied, they become how we do it here. And suddenly the board isn't enforcing policy, it's manufacturing precedent. That distinction matters. A policy is supposed to be a deterministic constraint. An exception is a fork in the security model. Enough forks and the tenant becomes a probabilistic system where outcomes depend on which historical workaround someone remembers to use. And then comes the most common lie, just document it. Documentation is not a control. It never was. Documentation is an explanation of intent written at a point in time by someone who had context that the next person won't. It decays faster than apps ship. It becomes stale the moment a connector is added, an owner changes, a label taxonomy evolves, or Microsoft updates the platform behavior. The result is predictable. The document becomes theater. It exists to satisfy a meeting, not to enforce a boundary. Auditors don't ask whether you have documentation. They ask whether you can produce evidence. Evidence is inventory, logs, ownership, and policy outcomes, not a Confluence page with a diagram from last year. This failure is amplified by fragmented authority. IT owns risk. Business owns outcomes. Security owns policy. Compliance owns penalties. The maker owns the thing until they don't. No one owns drift, and drift is the actual enemy. Drift means RBAC membership changes. It means service principles get created with broad permissions temporarily. It means environments proliferate because environment creation is easier than cleanup. It means DLP policies get tweaked per exception until enforcement becomes inconsistent across zones. When nobody owns drift, governance turns into a reactive service desk. And that service desk becomes the de facto control plane. Humans manually correcting a system that never encoded the intent in the first place. Here's the simple system law. If a governance decision can't be enforced automatically, repeatedly, and consistently, it's not governance. It's a request for someone's attention, and attention doesn't scale. At enterprise size, the demand for attention grows faster than headcount. Therefore, the review model creates chronic backlog. Backlog creates workarounds. Workarounds create security debt. Security debt creates incidents. And incidents create more review. It's a closed loop, a bad one. This is also why AI makes the human review model collapse faster. Agents and co-pilots don't just increase the number of apps. They increase the number of principles, tool calls, and data pathways. They create more decisions at runtime. If your control strategy is, we'll review it, you are volunteering to review an infinite stream of probabilistic behavior. You won't. So the goal isn't more governance. The goal is governance that doesn't require asking permission for every action. You move enforcement upstream, identity policy, provisioning gates, and DLP boundaries that exist at creation time, not incident time, because the only scalable review board is code. The hidden bill, support audit, and incident economics. Now comes the part nobody budgets for because it doesn't look like a project. It looks like operations. And operations in most orgs is treated like weather, inconvenient, inevitable, and somehow not caused by design decisions. App-first estates don't just create risk, they create recurring invoices paid in time, attention, and downtime. The hidden bill is what happens after the demo when the organization starts living inside the thing you shipped. Start with support. Support tickets are not random noise. They're a cost model. Every ticket is a micropayment for ambiguity. Missing ownership, unclear permissions, broken connections, expired credentials, who has access, why is this blocked, why did this flow stop, what environment is this even in, and tickets compound. One broken connection isn't one ticket, it's a chain. User reports failure, help desk triages, admin escalates, security asks whether data leaked, compliance asks whether the app is in scope, and the maker, if they still exist, says, it worked yesterday. That entire chain exists because the system didn't produce an authoritative answer by default. If you want an executive translation, AppSprawl converts governance into a subscription. You pay every month, forever. Next, audit economics. Auditors don't care that you have a governance process. They care whether you can prove control, and proof is expensive when it's manual. Evidence production becomes its own shadow project. Inventory exports, screenshots, exception lists, DLP policies, environment lists, connector usage, ownership lists, access reviews, incident logs. In a control plane world, that evidence is a byproduct. In an app-first world, it's a scavenger hunt, and the scavenger hunt costs more than the audit. Because it pulls senior people into data collection. It forces one-time remediation work. It creates fire drills where the goal becomes producing a binder, not improving the system. And the outcome is predictable. You pass the audit by heroics, then go right back to the same behavior that created the audit risk in the first place. Here's the uncomfortable detail. The most expensive part of audit work is not the policy writing. It's the gap between your intent and your inventory. If you can't answer what exists and who owns it reliably, you don't have governance, you have narrative. Now, incident economics. Incidents in low-code estates rarely start as a breach. They start as something boring. A service principal credential expires, a connector changes behavior, a mailbox gets disabled, a DLP policy blocks something that was never supposed to be production, a user shares an app with the wrong group, Copilot summarizes something it shouldn't. Then the blast radius decides whether the incident stays small. In an app-first tenant, blast radius boundaries are weak. Everything lives in shared environments, shared connectors, shared permissions, shared service accounts, so a small fault propagates. A broken account breaks 5 flows. A connector outage knocks over business processes nobody knew were automated. And because inventory is incomplete, incident response becomes discovery work under pressure. That is not incident response. That is archaeology with an SLA. License and capacity waste is the quieter part of the bill, but it's the easiest to explain to finance. Unused apps still occupy inventory, create confusion, and sometimes keep premium connectors alive. Duplicate solutions appear because nobody can find what already exists. Pay-as-you-go models punish surprise success. Capacity gets consumed by zombie artifacts because nothing retires by default. And the organization ends up funding innovation that is mostly redundant infrastructure. So the executive framing is simple and brutal. You can invest once in a control plane, or you can keep paying an operational tax for ambiguity. A control plane doesn't eliminate problems. It changes the unit economics of problems. It makes evidence cheap. It makes ownership durable. It makes drift visible. It shrinks blast radius by design. And this is why we need more admins is the wrong conclusion. More admins just means you're scaling human middleware. The system will still drift. The tickets will still arrive. The audit will still demand proof. The only sustainable move is to move governance upstream into identity, provisioning, and policy enforcement, so the organization pays in design once instead of paying in tickets forever. And that's the mental model shift we need next. What you're actually building when you say control plane. Control plane 101, the thing you're actually building. A control plane is not a product you buy, it's not a dashboard you show an auditor, and it's definitely not a governance initiative you launch and then forget. In architectural terms, a control plane is the part of the system that decides what is allowed to exist, who is allowed to create it, what rules must be true at creation time, and what happens when those rules stop being true. It is decision-making encoded. That distinction matters because most tenants already have governance artifacts, policies in a PDF, a naming standard, a COE SharePoint site, a Teams channel where people ask for approvals. None of that is a control plane. A control plane produces enforceable outcomes. If the outcome can't be enforced automatically, repeatedly, and without someone's memory, it's not control. It's hope with a ticketing system. Here's the cleanest mental model. Every modern platform has 2 planes. The control plane decides. The data plane executes. The data plane is the stuff people see. Apps, flows, approvals, connectors, copilots, dashboards, integrations. It's where value gets delivered. It's also where mistakes are easy to ship because value is visible and risk is not. The control plane is the stuff people avoid because it feels like admin work. Identity standards, policy engines, environment boundaries, lifecycle rules, inventory, telemetry, and automated evidence. But the control plane is where scale lives. Without it, every app becomes a snowflake. Every flow becomes a one-off. Every exception becomes permanent. And you spend your life explaining to executives why this should have been easy. So what does a control plane actually output? 4 things every time. First, identity outcomes. Not just who signed in, but which principles exist, how they authenticate, how they get permissions, and how those permissions get reviewed. Users, groups, service principals, managed identities, and now agents. These are the actors. If you don't govern actors, you can't govern actions. Second, policy outcomes. Conditional access, RBRC boundaries. Connector allow deny lists, DLP boundaries, tenant isolation rules, environment classification. Policy is not prose. Policy is compiled intent that results in an allow, block, or require more friction decision. Third, lifecycle outcomes. Creation, change, and retirement. Most orgs automate creation and ignore retirement. That is how you get 3,000 apps. A control plane treats retirement as a default behavior. Inactivity thresholds, owner verification, deprecation notices, quarantine pathways, and deletion gates. Fourth, observability outcomes. Inventory that answers what exists, telemetry that answers what changed, and evidence that answers can you prove it. If you can't observe drift, you can't claim control. You can only claim intent. Now the rule that makes architects uncomfortable. The control plane has to be upstream of the maker, not above them in hierarchy. Upstream in the flow of creation. If you let people create assets first and then ask for review later, you already lost. The asset exists, dependencies form, business value attaches to it, and you will not delete it. You will negotiate around it. That's how exceptions become architecture. So control plane engineering means you standardize the pathways assets are born through. It means creation is an API call or a governed template, not a free-for-all. It means ownership is enforced by design, co-owners, continuity identities, and rules that prevent single human dependency. It means DLP and connector policy are applied at creation time, not after a leak scares legal. It means the tenant generates its own inventory continuously, so audit evidence is not a quarterly panic. And yes, you can implement this inside Microsoft's ecosystem without inventing a new platform. Entra already behaves like a distributed decision engine. Graph already behaves like the provisioning bus. Purview already behaves like a policy enforcement layer. Power Platform already exposes environment and connector governance surfaces. The missing piece is not tooling, the missing piece is intent encoded as a system. So when someone asks, what are we building? The answer is simple. A programmable operating model that makes safe behavior the default and unsafe behavior expensive. Now we can talk about how Microsoft Stack already contains control planes, whether you use them or not. Microsoft Stack already has control planes, you're just not using them. Microsoft Stack already assumes you're operating a control plane. The only thing optional is whether you admit it and design it or pretend it's admin stuff and let it emerge as accidental behavior. Start with Entra ID. Most people still describe it as an identity provider. Users log in, tokens get issued, everyone goes home. That description is comforting. It's also incomplete. Entra is a distributed decision engine that sits in the middle of every meaningful action in Microsoft 365 and Azure. It evaluates who you are, what you're trying to do, what condition you're doing it under, and what policy should shape the outcome. That means Entra isn't a feature, it's the control plane substrate. And once you accept that, a lot of bad tenant behavior becomes explainable. When you let people create service principles with broad permissions, you didn't configure an app. And then you introduced a new non-human principle into the decision graph with a blast radius that outlives the project. The system will keep honoring that principle until you revoke it. The platform doesn't remember your original intent. It remembers your granted permissions. Then there's conditional access. Microsoft markets it as if this, then that. That is technically correct, but it hides the operational reality. Policies are additive, not prioritized. Multiple policies can apply to the same sign-in. Exclusions create alternate universes. And over time, the set of possible evaluations becomes too large to hold in a human head. Practitioners call this conditional chaos for a reason. Not because conditional access is unstable, but because humans treat it like a series of patches instead of a compiled model. A real control plane treats conditional access like a compiler. You feed it signals and assignments, and you expect deterministic enforcement outcomes. That requires testing, simulation, and lifecycle management of the policy set. If your CA strategy is, we'll add a policy when something scary happens, you're not building a model. You're building a pile. Next, Purview DLP. This is where organizations lie to themselves with checkboxes. They enable DLP and declare victory. But DLP is not a compliance sticker. It's a boundary enforcement layer across data pathways. Exchange, SharePoint, Teams, endpoints, and now Copilot prompts and AI interactions. The reason it feels inconsistent in many tenants isn't because the engine is random. It's because the estate is random and the coverage is uneven. And the AI era makes that unevenness painfully visible. In January 2026, Microsoft acknowledged a Copilot chat bug where confidential labeled emails in sent items and drafts could be incorrectly processed despite configured DLP policies. Microsoft's statement emphasized that access controls remained intact, but the behavior still violated the intended exclusion model. That incident isn't an argument to panic and block AI. It's proof that your control plane has to assume defects happen. Policy needs layers, monitoring, and verification. DLP is a control plane component, not a single line of defense. Now, Microsoft Graph, people keep calling it the developer API, which is the same category error as calling Entra just identity. Graph is the orchestration bus for the Microsoft Cloud. It's how you programmatically create, read, change, and retire objects at scale. Applications, service principles, groups, users, configurations, and the inventory metadata you keep pretending you'll track manually. And Graph has distinct patterns for scale, real-time transactional calls for operational changes, event-driven notifications for low-latency change detection, and data connect for bulk, scheduled exports when you need to analyze an entire tenant without melting the API limits. In other words, Graph is how you stop doing governance as artisanal portal clicking. It's how you turn lifecycle and inventory into repeatable system behavior. Finally, Power Platform's admin surface. The admin center exists because the platform designers already know what your estate will look like at scale. Environments proliferate, connectors sprawl, ownership decays, and temporary becomes permanent. The tooling supports environment strategies, DLP policies, connector governance, and analytics. But tooling isn't architecture. Without an operating model, the admin center becomes a dashboard of regret. So the uncomfortable conclusion is this. You already have control planes. You're already paying for them. You're just using them like a set of disconnected admin pages instead of a single programmable system that enforces intent. And when you do that, you get exactly what the system produces by default: conditional chaos, connector creep, orphaned principles, and an audit story held together by screenshots. Next, the fix is not use more Microsoft. The fix is to anchor on 3 components and engineer them like infrastructure: an identity policy engine, graph-based provisioning, and a DLP enforcement layer. Component 1. Identity policy engine. The first control plane component is the identity policy engine, because everything else is just a different way to ask the same question. Who is allowed to do what, to which data, using which tools, under which conditions? Most tenants try to govern apps. That's backwards. Apps are outputs, principals are causes, users, groups, service principals, managed identities, and now agents. Those are the entities that actually execute actions. If you don't govern principles, you can't govern outcomes. You just chase artifacts after they already exist. This is also where least privilege stops being a slogan and becomes architecture. In practice, least privilege is three constraints that have to be true at the same time. The identity has to be scoped to the minimum role or permission set, that scope has to be bounded to the right resource boundary, and the assignment has to expire or be reattested, so drift doesn't turn a temporary grant into a permanent liability. And drift is not a special case. Drift is the default state of enterprise identity. People move teams, groups get repurposed, projects end, service principles get created for one proof of concept and then quietly become production dependencies. Someone grants directory, read-write, all at 2 a.m. to unblock the deployment, and nobody ever revisits it because the deployment succeeded. Therefore, the decision is socially invisible. The system did exactly what it was told. That means the identity policy engine has to treat policy as durable under change, not perfect under assumptions. It has to survive the reality that role assignments will change, ownership will decay, and new principles will appear faster than you can review them. This is why identity governance has to be principle first, not app first. Every principle should have three things encoded: an owner, a purpose, and a lifecycle boundary. Not someone knows, but a declared chain of accountability that can be queried, audited, and enforced. If you can't name an owner, you don't have an identity. You have a ghost with permissions. Now, conditional access sits on top of this, and most organizations treat it like a bag of rules. That's how you get conditional chaos. The more accurate model is to treat conditional access like an authorization compiler. It takes inputs, signals like user risk, sign-in risk, device compliance, location, client type, and compiles them into enforcement outcomes: allow, block, require, MFA, force compliant device, apply, session controls. That compiler analogy matters because compilers demand discipline. You don't just add a policy, you define intent. You test permutations, you avoid overlapping logic that creates unpredictable behavior, and you version changes like you would any other critical system. Otherwise, you're not building a security model, you're writing fortune-telling rules and hoping the next incident doesn't find the gap. There's also a subtle identity mistake that shows up in Power Platform and M365 automation estates. People govern interactive users aggressively, then ignore non-human identities completely. The result is hilarious in the darkest possible way. Humans get MFA prompts and access reviews, while service principals run with broad permissions for years because nobody wants to break the automation. So the identity policy engine has to govern workload identities as first-class citizens, service principals, managed identities, app registrations, and agent identities. These are not implementation details. They are the fastest growing risk surface in modern tenants. And yes, agents make this worse, not because agents are magical, but because they increase the number of principals that can act. An agent that can call tools is effectively a principal that can execute workflows at machine speed. If you let that identity inherit broad access because we'll monitor it, you've moved from deterministic security to probabilistic damage control. So what does deterministic intent look like in identity terms? It looks like separation of duties encoded in roles, not implied by org charts. It looks like access reviews that are tied to real ownership and real usage, not calendar reminders. It looks like policies written as if an auditor will ask tomorrow, show me why this identity needed this permission and who approved it. And it looks like denying the dangerous convenience path, defaulting to broad scopes because it's easier than designing boundaries. Because the whole point of a control plane is to remove human review from the hot path without removing accountability. Identity policy does that by making the allowed pathways obvious and the forbidden pathways expensive. Once identity is engineered this way, the rest of the control plane becomes possible. Provisioning stops being artisanal portal work and becomes repeatable orchestration. But provisioning without identity guardrails is just faster sprawl. So next, graph-based provisioning as the orchestration backbone. Component 2, graph-based provisioning as orchestration backbone. Once identity is engineered, provisioning becomes the next choke point. And most organizations treat provisioning like a set of one-off errands. Someone creates an environment, someone makes a group, someone registers an app, someone grants a permission, someone documents it, and everyone prays it stays true. That is not provisioning, that is artisanal tenancy. Graph-based provisioning is the move from people-click portals to the tenant is programmable. Microsoft Graph is the plumbing that already exists for this, a unified endpoint that lets you create, read, change, and retire objects across Microsoft 365 and Entra, not as a developer flex, as an operating model. Here's why this matters. A control plane doesn't scale by having better humans. It scales by having repeatable pathways. Graph is how you standardize the pathways assets are born through, and it immediately forces an uncomfortable discipline. If you can't express your lifecycle rules as an API operation, your lifecycle rules aren't real. They're social agreements. Graph enables two provisioning patterns that most teams confuse. The first is real-time transactional provisioning. Someone requests an app, a flow, a group, a service principal change, a permission update, and Graph executes it. That's the wiring model. Predictable inputs, predictable outputs, with logs and request IDs that actually mean something. The second is bulk and asynchronous governance. When you need to answer tenant-wide questions, inventory, ownership drift, connector usage, high-risk principles, you don't spam the live API and hope throttling doesn't ruin your week. You use the right pattern. Scheduled bulk exports via Graph Data Connect when available, change notifications where they fit, and event-driven signals where you need low-latency awareness. The point is not which feature is trendy. The point is you design for scale instead of discovering scale at 3,000 apps. Now, the part most people get wrong, permissions. Provisioning automation wants app-only permissions because nobody wants a service account with MFA as a runtime dependency. Auditors want least privilege and clear blast radius. Those desires collide directly, and this is where control planes either become mature or become a security incident with better branding. Graph has a delegated permission model and an application permission model. Delegated is user context. The call acts as a human. Application is daemon context. The call acts as the app. For a control plane, app only is usually unavoidable, but it must be engineered like a workload identity with strict boundaries, ownership, and continuous review. Otherwise, you just created the most powerful ghost in your tenant. So the orchestration backbone needs a discipline. Separate the provisioner identity from the workload identities it creates. The control plane principle should have only the narrow set of graph permissions required to enact approved patterns. No browsing rights out of convenience, no directory-wide write access because it was faster, and no, we'll tighten it later. Later never comes. Later becomes drift. And Graph will punish you operationally if you treat it like an infinite resource. Quotas and throttling exist, and that's not Microsoft being annoying. That's the platform telling you something architectural. Your provisioning system must tolerate retries, back-off, and partial failure. So the orchestration logic has to behave like production code, even if you built it with low-code tools. So you design idempotency, you log every request with correlation IDs, you respect retry after headers, you implement dead letter paths for failures. Because if your control plane collapses under throttling, you didn't build governance. You built a denial of service against your own operating model. This is also why wiring, not firefighting, is the only mindset that works. When provisioning is repeatable, you stop solving the same problem as a new incident every week. You stop negotiating how an environment gets created. You stop arguing about naming. You stop playing detective on who owns what. The control plane makes those outcomes default. But there's a trap here, and it's the one that destroys most automation initiatives. Provisioning without policy gates just accelerates sprawl. If your graph workflow can create apps faster than your identity and DLP boundaries can constrain them, you're not building a control plane. You're building an app factory that produces faster entropy. So graph-based provisioning has to be coupled to your policy engines. Every create operation needs a classification decision. Which zone, which connector set, which ownership rule, which retention and audit requirements, which DLP policy applies at birth. Provisioning isn't just create. It's create inside constraints. That's why Graph is the backbone, not the whole body. It's the orchestration bus that makes lifecycle real. Standardized creation, enforced ownership, automated retirement triggers, and continuous inventory. Identity decides who can act. Graph makes action repeatable. Now you need the third layer to stop data pathways from turning into leaks. DLP as an enforcement boundary, not a compliance checkbox. Component 3, DLP enforcement layer. The third control plane component is DLP because identity and provisioning don't matter if data can still drift into the wrong places through perfectly valid connectors. DLP is not a compliance checkbox. It's boundary enforcement across data pathways. Which connectors can talk to which connectors, which content can be processed by which experiences, and which actions should be blocked, audited, or allowed with friction. And it has to be designed like a system boundary, not a moral guideline. Here's what most people miss. Connectors are not integrations. Connectors are egress routes. They're how data leaves the governed backbone and finds its way into a consumer service, a personal mailbox, a random spreadsheet, or now an AI prompt. So when a tenant says, we'll just turn on DLP, but continues to allow unrestricted connector pairing in a single environment strategy, what they've built is not governance. It's conditional chaos with a different label. Power Platform makes this painfully concrete. DLP policies classify connectors into business and non-business groups so they can't be combined in the same app or flow. That's the advertised mechanism. The actual architectural job is deciding what the business group even means per zone. A zone strategy is the only model that survives scale. Green zones for exploration, yellow zones for internal productivity, red zones for regulated workloads. Same platform, different risk posture, different connector allowance, different evidence expectations. Otherwise, you get the default environment gravity problem again. Everything lives in one place because it's convenient, and you try to enforce enterprise controls on a playground. That doesn't work. It just trains people to route around the control. So the DLP control plane output is not a policy exists. Its unsafe pairings are impossible by default in the zones that matter. Now, DLP gets even more interesting and more uncomfortable when you bring Copilot into the estate. The common executive belief is that Copilot is just a UI over Microsoft Graph. Therefore, the existing permission model will handle it. That's only half true. Copilot's grounding honors access boundaries, but it also creates new processing surfaces, prompts, summaries, citations, and cross-app experiences where label enforcement is not always consistent. And we have real evidence of that. In January 2026, Microsoft tracked an incident, Service Advisory CW1226324, where Copilot Chat could incorrectly process confidential labeled emails from sent items and drafts, despite configured DLP and sensitivity label controls. Microsoft fixed its server side and stated it didn't grant users access to anything they weren't already authorized to see. That statement is legally tidy. It's also architecturally irrelevant. The lesson is simple. Defects happen at the seams, so your DLP design can't assume labels always block everywhere. It has to assume partial coverage, inconsistent enforcement across experiences, and the need for monitoring to detect when the system's promise and the system's behavior diverge. That's what control plane thinking looks like. Controls are layered, tested, and observed, not declared. Practically, that means you use two DLP modes in parallel. First, Power Platform connector governance at the environment level. Allow-deny lists per zone, restricted high-risk connectors in production, and a clear exception pathway that is engineered as a workflow, not an email to a person. In Wave-era tooling, Microsoft keeps adding more admin controls to do this, but the architecture remains the same. You decide where connector freedom exists and where it doesn't. Second, Purview DLP for Copilot and Copilot Chat, policies that restrict processing based on sensitive information types and sensitivity labels. But here's the uncomfortable rule. Label-based controls only work if labeling maturity exists. If your tenant labels nothing, DLP protects nothing. If your tenant labels inconsistently, DLP behaves inconsistently. The system can't enforce what you didn't classify. So DLP becomes a forcing function for data hygiene. Not because compliance wants it, but because AI makes poor classification visible. People don't fear a folder full of unlabeled documents until Copilot can summarize them in 5 seconds. Now, none of this means DLP is perfect. There are known limitations, coverage gaps across scenarios, propagation delays, and the reality that you can't always combine every condition in a single rule set the way you'd want. That's not an argument against DLP. It's an argument against betting your entire governance story on a single enforcement feature. The control plane approach is to design DLP like a boundary layer with assumptions, where it's strong, where it's weak, and what compensating controls exist when it's weak. Identity decides who can attempt access. Provisioning decides what can be created and where. DLP decides whether data pathways behave inside acceptable boundaries, and the principle that ties it together is the one most orgs keep refusing to accept. Trust is engineered, not assumed. Now that the 3 control plane components are defined, the next step is to make the shift real with the first case study, the Power App explosion, and what it looked like when governance moved from manual review to graph-driven lifecycle by design. Case Study 1, Setup, Power App Explosion, Governance through Graph. The first case study starts the way these stories always start, with success. Power Platform landed, a few teams built a few useful apps, leadership saw quick wins, and the organization did the only thing it knows how to do with quick wins. It scaled them. Within a couple years, the tenant carried north of 3,000 apps and flows. Some were legitimate, well-built solutions. Most were tactical utilities that outlived their moment, and the estate wasn't out of control in the dramatic sense. It was worse. It was undefined. Ask 10 people what the app estate looked like, and you'd get 10 different answers. Because there was no system of record. There was no authoritative inventory with ownership, connector pathways, environments, and lifecycle state. There were just scattered lists, a COE site that was always behind, and a general belief that we can always find it later. Later arrived. The first thing that broke wasn't security, it was support. Tickets started climbing, and not because apps were inherently fragile. Tickets climbed because the tenant couldn't answer basic questions at speed. A flow failed, a team asked who owned it, and the answer required archaeology. Open the flow, check connections, find the maker, discover the maker left, escalate to admin, and then watch 3 different teams argue about whether this was a business app or IT owned. The queue filled up with identity and ownership problems disguised as app issues. And then the quiet killer showed up. Departed employees as owners. When a maker leaves, the app doesn't stop existing, it just stops being maintainable by the people who depend on it. Connection references age, secrets expire, APIs throttle, licensing changes, and suddenly a business-critical process has no steward. The platform didn't fail. The operating model failed to encode continuity. The second breaker was the default environment. Everything temporary lived there. Proof of concepts, side projects, team utilities, and then, predictably, the things that delivered value became dependencies. Nobody wanted to move them because moving implies governance, and governance implies time. So the default environment became the production environment that nobody calls production. That's where DLP started to feel inconsistent. In some environments, connector policies were strict. In others, exceptions piled up. In the default environment, the rules were whatever still works. People experienced DLP as arbitrary because enforcement differed across zones, and zones existed by accident, not by design. So makers learned the fastest pathway: build where the policy is weakest, then ask for forgiveness when someone notices. Connector creep followed. A flow here used a consumer connector because it was convenient. An app there used a premium connector because it was just for this one team. Over time, connectors stopped being a technical choice and became a governance problem. Each connector created a new data pathway with audit obligations, licensing implications, and risk questions nobody could answer quickly. The first audit scare made the problem visible. The auditors didn't ask for a philosophy, they asked for evidence. List the apps and flows that touch regulated data, show owners, show connector usage, show how DLP prevents unsafe pairing, show how levers don't leave behind active automations, show how exceptions are tracked, show how you retire unused assets. The organization had policies and documents. It did not have evidence at scale, so they did what enterprises do in that moment. They formed a task force and produced a binder. They passed the audit on heroics, and then they went right back to the same operating model that required heroics. At this stage, the executive misconception was predictable. We need more admins. That's the comforting answer because it sounds like capacity. It is not. It's human middleware. It would have increased throughput temporarily, then failed permanently because the estate kept growing and the decision model stayed manual. The pivot came when someone finally asked the right question. Why are humans the policy enforcement mechanism? Instead of adding reviewers, they started treating governance as an engineering problem, a control plane problem. And they anchored success on a metric executives actually understand, not number of apps governed, not percentage of makers trained, not DLP policies created, support tickets. They defined a governance-related ticket category: ownership changes, access requests, connector exceptions, DLP blocks, environment drift, broken connections caused by lifecycle decay. Then they measured baseline volume and cycle time. That number became the truth serum because it captured friction from every missing control. The target was simple: cut that ticket volume by around 40% without slowing down delivery. Not by policing makers harder, by changing how the tenant creates, owns, classifies, and retires assets by design. Now, the important part, the shift wasn't use Microsoft Graph. The shift was to govern through Graph, meaning the control plane could create inventory, enforce ownership, and drive lifecycle outcomes automatically at the moment assets are born. That's what we'll walk through next. The control plane shift, not the tool list. Case study 1. Control plane shift, lifecycle by design. They didn't clean up apps. They changed the birth mechanism. That's the control plane move. Stop treating creation as a personal act in a maker studio and start treating it as a governed pathway with enforced defaults. The estate didn't need more training. It needed fewer degrees of freedom in the places that create irreversible mess. So the first change was graph-based provisioning, but not in the shallow we used in API sense. They defined standard creation pathways. If you wanted a production-capable app or flow, you didn't start in the default environment and hope for the best. You requested a governed artifact, and the control plane created it with pre-attached metadata. Owner, business purpose, environment classification, connector tier, data sensitivity expectation, support model, all written at creation time, because anything not captured at creation time becomes a myth later. Microsoft Graph became the plumbing for the lifecycle objects that matter. App registrations, groups, ownership links, and the inventory that ties these to Power Platform assets. The point wasn't to manage every click. The point was to make the tenant produce a reliable ledger of what exists. Then they enforced ownership continuity as a hard rule. No single human owners, ever. Every critical app and flow required at least 2 human co-owners, plus a continuity identity that survives org charts, a service account or team-owned group with controlled membership. Not as a best practice, as a creation gate. If the ownership graph wasn't complete, the artifact didn't get created in the governed zone. This one rule removed an entire class of tickets. Not because it prevented people leaving, but because it prevented leavers from becoming outages. Next came automated retirement, and this is where most orgs flinch because they're emotionally attached to the idea that deletion is dangerous. It is, but unmanaged permanence is worse. So they engineered retirement like a lifecycle product. Inactivity thresholds, staged notifications, and deletion gates with quarantine pathways. If an app hadn't been used or modified in a defined period, the control plane marked it as candidate. Owners got notices with a simple choice: attest it's still needed, assign a new owner, or accept deprecation. No response didn't mean keep forever. No response meant move toward retirement, because silence is not governance. And for flows, they used run history and failure patterns as signals. Dead flows weren't legacy, they were liabilities. The control plane treated repeated failures, broken connections, and missing owners as risk indicators that triggered intervention automatically. DLP moved from policing to gates. Instead of waiting for makers to discover that a policy blocks them after they've already built the thing, the control plane applied DLP at creation based on environment classification. Green zone, permissive connector set for exploration with clear warnings and limited data scope. Yellow zone, approved business connectors only with tighter sharing rules. Red zone, strict allow lists, premium connector restrictions, and stronger auditing expectations. That zoning strategy did something important. It made where you build a security decision, not a convenience decision. And it made DLP feel consistent again, because enforcement mapped to explicit zones instead of accidental environments. Connector governance followed the same logic. Connectors weren't treated as features. They were treated as data pathways with cost and audit obligations. High-risk connectors required an engineered exception workflow: request, justification, time-bound approval, and automatic review. No more email and admin and hope. Exceptions became a formal part of the control plane because unstructured exceptions are how policy becomes theater. Then they automated evidence production, which is the part executives never believe is possible until it's done. Inventory became continuous, not quarterly, not when audit asks, continuous. They generated a tenant-level view of assets with the fields auditors and incident responders actually need. Asset type, environment, owners, connectors, last run, last modified, sharing scope, and a simple risk tier. They didn't pretend risk scoring was perfect, they made it legible. And because it was legible, they could route attention correctly. Red tier assets got tighter review and monitoring. Green tier experiments got freedom without pretending they were production safe. The outcome wasn't a cleaner spreadsheet, it was changed system behavior. Makers still built, but they built through pathways that produced ownership, boundaries, and life cycle by default. Admins stopped acting as human control planes because the control plane started doing what systems are supposed to do: enforce assumptions automatically. This is the part that matters for the next case study sections. They didn't win by centralizing everything. They won by standardizing the rules of creation and by making the cost of bypassing those rules higher than the cost of doing it right. And once lifecycle became design, not cleanup, the ticket curve finally had a reason to bend. Case study 1. Outcomes. What changed system behavior? Here's what changed after the control plane shift. Not the number of apps, not the maker enthusiasm, not the amount of innovation. System behavior changed. And that's the only thing worth measuring, because outputs are easy to fake, behavior is not. The headline metric was support tickets. Governance-related tickets dropped by 41%. Not because users suddenly became experts. Not because admins worked harder. Because the tenant stopped generating ambiguity by default. Ownership stopped being a mystery. So who owns this tickets evaporated. Creation stopped happening in random places, so why is this blocked here but not there? Tickets stopped being a weekly argument. Connectors stopped being surprise data pathways, so we didn't know this flow was exporting data to that service. Stopped showing up as panic disguised as troubleshooting. The system started answering the basic questions for them. That's what a control plane does. It turns questions into queries, not investigations. The second measurable change was audit evidence production. They measured it in elapsed time, not in how confident the compliance team felt. Evidence production got 60% faster. That number isn't magical, it's mechanical. Before, evidence required assembling fragments, portal exports, screenshots, emails, and someone's memory of why an exception existed. After, evidence was a byproduct of operating the system. Inventory existed, ownership was enforced, connector use was visible, environments were classified, and retirement signals were recorded. Auditors didn't become nicer. The organization just stopped treating audits like an annual scavenger hunt. The third change was unused assets. They saw a 28% reduction in unused apps. Not because someone finally found time to clean up, because retirement became default behavior. That's the deeper outcome. The estate stopped growing purely by accumulation. It started shrinking where value didn't exist anymore. And that matters, because an estate that can't shrink is not an estate. It's a landfill with a UI. Now, if you're listening and thinking, okay, so they got lucky, good. That skepticism is healthy. This is correlation, not physics. But the architecture created the conditions for those outcomes. And that's the distinction most exec decks ignore. You don't buy a 41% reduction. You build a system where the same class of failure can't reproduce at scale. What actually improved was determinism. Before, the tenant behaved like a probabilistic system. Outcomes depended on which admin you got, which exception someone remembered, which environment a maker happened to use, and whether the original owner still existed. The same action could produce different results on different days. That's not governance, that's roulette with compliance penalties. After the control plane shift, outcomes became predictable. Production assets were born in known zones, with enforced ownership, known connector boundaries, and lifecycle hooks that triggered retirement and evidence generation. Accountability became durable. Not we think Bob owns it. Actual owner links that survive org charts because co-ownership and continuity identities were mandatory. That single design choice shrank the blast radius of departures. People still left. The tenant stopped caring. Auditability became cheap. Not free, cheap. Because the estate produced its own ledger continuously. You could ask questions like, show me all flows in red zones using premium connectors with no successful run in 30 days and no continuity owner. That's not a meeting, that's a filter. And the most important cultural shift, admins stopped being the hot path. They still existed, they still governed, but they stopped being required for every correction. The system stopped demanding attention for routine lifecycle work. That's the win. Because at enterprise scale, attention is the rarest resource. Not licenses, not connectors, not templates, attention. Now the story has to move beyond Power Platform and M365, because the same failure mode exists in Azure, just with different nouns. Power App Sprawl becomes subscription sprawl. Makers become workload owners. Connectors become role assignments and policies. And the same question returns. Are you governing outputs, or are you engineering the control plane that makes those outputs safe by default? Case Study 2 Setup. Azure Policy Chaos. Identity-driven guardrails. The second case study looks like a completely different problem. Different teams, different portal, different vocabulary, same failure mode. It started with cloud adoption, which is corporate speak for we created subscriptions faster than we created a way to govern them. Over time, the estate grew into hundreds of subscriptions, some mapped cleanly to business units, some mapped to projects, some mapped to experiments that became production because nobody wanted to do the migration paperwork. And because every subscription came with its own RBAC graph, its own policy assignments, and its own set of exceptions, governance didn't scale. It fragmented. At first, it felt manageable, a few Azure policies, a few naming standards, a few mandatory tags. And then reality arrived. Engineers needed speed, security needed guardrails, and finance wanted cost attribution yesterday. So exceptions became the only thing that moved quickly. This is the foundational mistake, treating Azure policy as paperwork. Azure policy is enforcement. But when it's implemented like documentation, written once, rarely tested, and constantly bypassed, it becomes an artifact of intent, not a mechanism of control. And that's when the environment flips from deterministic to probabilistic. The rules exist, but outcomes depend on who deployed the resource, which template they used, and whether anyone noticed the exception. The first visible symptom was RBAC drift. Roles got assigned for emergencies. Owners got added temporarily to unblock pipelines. Custom roles appeared because someone didn't want to learn the built-in ones. Groups got repurposed because it was faster than requesting a new one. And nobody had a reliable answer to the simplest question, who can do what, right now across the estate? Then came the quietest high-risk asset class in Azure. Orphaned service principals. Service principals don't complain. They don't submit tickets. They don't leave the company. They just keep working with whatever permissions they were granted at the moment someone needed something to run. Over time, the directory accumulated workload identities with broad rights, unknown owners, and credentials that rotated only when something broke. Some of them held API permissions, some held subscription owners, some held rights to key vaults and automation accounts. And because they were created as implementation details, nobody treated them as governed principles. That is always how it goes. The second symptom was tagging and naming inconsistency. This sounds petty until you run a FinOps review or an incident. If resources aren't tagged consistently, cost attribution becomes political theater. Every spend report becomes a negotiation. If naming isn't consistent, incident response becomes slower, because responders can't tell what a resource is for, who owns it, or whether it's safe to isolate. The organization loses visibility and then tries to buy visibility back with another tool. And then audit pain arrived. Not we failed an audit pain. Worse, we can't answer basic audit questions without assembling a team pain. Evidence lived in too many places. Azure portal exports, Defender alerts, random spreadsheets, tribal knowledge, and screenshots saved in Teams chats that nobody can find during an audit. The auditors weren't asking for perfection, they were asking for control proof, access governance, exception handling, policy coverage, and remediation evidence. And the organization could only answer with heroics. That means they didn't have a system. They had people. Now here's the trap that kept this estate stuck for years. They tried to govern resources directly. They tried to review every subscription, every resource group, every policy assignment, every exception, every role assignment. That sounds responsible until you do the math. At hundreds of subscriptions and thousands of resources, human review becomes a denial of service against governance itself. So the organization did what humans do. They prioritized the loudest problems. And the quiet problems, service principles, inherited permissions, stale role assignments, kept accumulating. This is the uncomfortable truth. Azure resource governance fails when identity governance is weak. Because Azure policy can constrain configurations, but it doesn't fix who is allowed to bypass the constraints. RBAC defines the bypass paths. Workload identities and admins define the blast radius. If you don't govern the principles, your policy engine becomes advisory. The pivot point in this case study was when they stopped asking, how do we review more? And started asking, how do we remove review from the hot path? They reframed the system around identity-driven guardrails, govern workload identities, standardize provisioning patterns, and make exceptions explicit, time-bound, and observable. Not because it's cleaner, because at this scale, it's the only model that behaves predictably. Case study 2, control plane shift, blueprinted provisioning plus conditional enforcement. So they stopped trying to fix Azure by reviewing Azure. They rebuilt the upstream system that creates Azure. The first move was identity standards for workloads, not we should use managed identities as a suggestion. A real standard. Every workload identity needed an owner, a purpose, and a life cycle. If it couldn't be tied to a team and a service, it didn't get created. If it didn't have a rotation and review story, it didn't ship. They treated service principles as production infrastructure because that's what they are. Then they drew role boundaries like they expected abuse, not like they expected everyone to be well behaved. Subscription owner became a rare, time-bound role. Contributor stopped being the default. Custom roles weren't banned, but they were treated as an exception pathway with review and expiry. Access reviews weren't calendar theater either. They were tied to workload identity ownership and real usage, so stale grants got revoked without a committee meeting. And they attacked the quiet time bomb, orphaned service principles. They didn't do it by scanning once. They made orphaning structurally harder. Every new app registration required enforced ownership links and a continuity group. Every credential had to be rotated through a controlled process. And if a principal had no owner, it got quarantined into a remediation workflow, not disabled immediately because production is messy. Quarantined, visibility, time box, and consequences. Next came conditional access. And this is where the story gets uncomfortable for people who still think CA is only about users. They began applying CA more deliberately to admin pathways and privileged access because the bypass routes were the actual governance problem. They didn't promise CA could solve every workload identity issue. It can't. But it can shrink the uncontrolled routes humans use to change the tenant. Unmanaged devices, legacy auth, and casual elevation. They aligned CA policies to the identity standards they just defined, and they treated CA changes like code, scoped, tested, and versioned. No more policy piles, no more permanent exclusions because the build agent broke once. Then they moved policy enforcement upstream into provisioning. This is where the blueprinted provisioning shift happened. They stopped letting teams create subscriptions as artisanal snowflakes. Subscription creation became a controlled pattern, a blueprint that included naming, mandatory tags, baseline policies, diagnostic settings, logging destinations, and RBAC scaffolding. Not because templates are pretty, because templates are enforceable intent. Provisioning created the subscription with the guardrails already attached. If a workload needed an exception, the exception wasn't a side conversation. It was a declared input into the provisioning workflow, time-bound, logged, and reviewable. Exceptions stopped being invisible. They became first-class objects with owners and expiry dates. Tagging enforcement followed the same design rule. If finance and security both need tags, tags can't be optional. They used policy as code thinking, required tags at creation, auto-remediation where possible, and an engineered exception path where auto-remediation couldn't work. That mattered because it eliminated the will fix tags later lie. Later is where visibility dies. They also built lifecycle automation into access itself. Roles didn't live forever. Privileged grants expired by default. Credentials rotated on schedule. Stale identities got flagged when they stopped being used, not as a quarterly review, as a continuous hygiene loop. And they finally treated drift as telemetry, not as a surprise. If someone assigned an out-of-policy role, that wasn't someone made a mistake. That was a control plane signal. The system recorded it, routed it, and forced a decision. Justify, remediate, or revoke. Governance stopped being a spreadsheet. It became an event stream. Now, it's worth saying out loud, none of this required them to centralize every engineering decision. Teams still deployed resources. They still chose architectures. The control plane didn't design their applications, it designed their boundaries. That's the separation that makes this work at scale. The data plane stays flexible, but the control plane stays deterministic. And yes, they still had exceptions. They just stopped pretending exceptions were temporary without engineering. Every exception had an owner, an expiry, and evidence. Because an exception without those three things is not flexibility, it's erosion. So by the time a subscription existed, it already had identity guardrails, policy baselines, logging, tagging, and a known authority chain. When auditors asked, how do you ensure consistency? The answer wasn't, we try. The answer was, we don't allow inconsistent creation. And when an incident happened, they didn't start with discovery. They started with inventory. That's the whole point of blueprinted provisioning plus conditional enforcement. Governance moves upstream, and the runtime stops paying for ambiguity. Case study 2 outcomes: reduced drift, reduced spend, cleaner audits. The outcomes in this Azure case weren't better documentation or more alignment meetings. The outcomes were mechanical changes in drift, spend, and audit behavior because the control plane moved upstream. First, misconfiguration dropped. They measured it as the count of non-compliant environments and policy violations that required manual remediation. That number fell by 35%. And the reason wasn't that engineers suddenly cared more. It's that variation stopped being a creative act. When subscription creation moved to a blueprint pathway and when identity guardrails shipped at birth, a large category of mistakes stopped being possible, not less likely, not caught faster, not possible inside the governed path. The estate became boring in the best way. Same baselines, same diagnostics, same tags, same RBAC scaffolding, same exception model. Drift didn't disappear. Drift became legible. If someone made an out-of-policy assignment, it showed up as a control plane signal with an owner and an expiry path. Instead of teams arguing about intent after the fact, the system forced a choice while the context still existed. Justify it, remediate it, or revoke it. That single shift, turning drift into an event, not a surprise, changed the entire operating posture. Second, cloud spend dropped. 22% attributed to lifecycle automation and reduced waste. Again, no magic, just physics. When tagging becomes enforceable, cost attribution stops being a political debate and becomes a query. When ownership becomes durable, resources stop living forever because nobody wants to delete someone else's work. When privileged access expires by default, fewer people can create just-in-case infrastructure that nobody ever revisits. When orphaned identities get quarantined, zombie automation stops running unnoticed. FinOps always wants to believe the problem is price. It isn't. The problem is unowned persistence. A control plane reduces spend by attacking persistence at the source. Who can create, under what pattern, and what happens when the creator disappears. Third, audits got clean. They passed with zero major findings, not because the auditors were generous and not because the security team finally found the perfect slide deck, because evidence became a byproduct of normal operations. They could show the blueprint pattern for subscription creation. They could show the identity standards for workload principles. They could show access review results tied to ownership and usage. They could show the exception pathway and its expiry behavior. They could show policy assignments as defaults, not as best effort retrofits. They could demonstrate that remediation wasn't dependent on someone noticing a spreadsheet row. That distinction matters. Auditors don't reward intention, they reward repeatability. The bigger behavioral change was speed of response. When incidents happened, responders didn't start by discovering what existed. They started with inventory. Which subscription, which workload identity, which role assignments, which policies, which exceptions, which logging destinations. The control plane shortened the time to truth because it made the estate queryable. And then there's the uncomfortable part, the exceptions. They still had them, they always will. But exceptions stopped metastasizing because exceptions had a life cycle. An exception without an owner or an expiry wasn't flexibility. It was a defect, and defects got routed, not tolerated. This is where the identity-first model pays off long-term. When you govern the principles and the provisioning patterns, you stop trying to govern every resource with human attention. You govern the boundaries that create resources, and the system enforces consistency at the scale humans can't. So yes, Azure policy chaos became predictable. Not perfect, predictable. Reduced drift, reduced spend, cleaner audits. And that sets up the modern problem, Copilot and Shadow AI. Because AI doesn't add a new app. It adds a new class of principles, new processing surfaces, and a probabilistic layer of behavior that will happily root around whatever you only enforced in meetings. Next, the third case study where executives want to block AI, and the correct answer is to build an agent control plane instead. Case study 3, setup, Copilot plus Shadow AI, central agent governance. The third case study begins with a familiar executive reflex. We should slow down. Copilot shows up, people get excited, a few early wins land. Then security asks the obvious questions. What data will it see? What will it summarize? What will it send? What will it accidentally reveal? And leadership briefly considers the simplest option. Block it, delay it, wait for the platform to mature. That instinct feels responsible. It's also how shadow AI is born. Because the business problem doesn't pause just because governance is uncomfortable. People still need drafts, summaries, answers, automation. If sanction tooling feels slow or uncertain, they route around it with personal accounts, browser plugins, unofficial copilots, and temporary connectors that never go away. The tenant loses visibility and the organization loses the ability to claim control with a straight face. So the starting state in this case wasn't a single Copilot rollout. It was a scattered pattern. Teams experimenting with Copilot in M365, departments building Copilots in Copilot Studio, makers stitching together AI-adjacent flows, and employees quietly pasting content into external models because it was faster. And the fear wasn't irrational, it was just poorly specified. The core risk wasn't AI might leak data in the abstract. The risk was that AI introduces more runtime decisions, more execution surfaces, and more non-human identities that can act at scale, while enforcement remains uneven across experiences. This is where the platform reality collides with the boardroom narrative. Executives kept asking, does Copilot respect permissions? Yes, in the foundational sense, Copilot inherits the Microsoft 365 permissions model. It doesn't magically read what a user can't access. But that's not the only question that matters. The real question is, can the tenant consistently enforce its intent across every AI entry point, every prompt surface, every connector, every agent, and every downstream tool call? And in the AI era, that answer is not automatically yes, even if your identity model is clean. There are two reasons. First, enforcement surfaces differ. Sensitivity labels and DLP don't behave uniformly across every Copilot scenario and every app. Microsoft documentation already acknowledges that label-based exclusions can apply in some Office apps but remain available in other scenarios like Teams or Copilot Chat. The system is improving, but it is not a single, perfectly consistent policy boundary. Second, defects happen at the seams. This isn't theoretical. In January 2026, Microsoft acknowledged a bug, Service Advisory CW1226324, where Copilot Chat could incorrectly process confidential labeled emails in sent items and drafts, despite configured DLP and sensitivity label controls. Microsoft stated access controls remained intact and that no one gained access they weren't already authorized to see. Fine, legally neat, operationally irrelevant. The point is that the exclusion model failed its promise in a real production tenant experience. So the organization in this case had the same problem every mature tenant eventually has. Trust eroded. Not because Copilot was unsafe by design, but because the organization had no way to prove continuously that controls behaved the way they thought they behaved. They could say, we have labels. They could say, we enabled DLP. They could not say, we can verify enforcement across experiences and detect drift or defects quickly. Meanwhile, Shadow AI kept expanding the principal count. Copilots, plugins, connectors, automation accounts, service principals, agents that call tools. Each one is a pathway. Each one is a blast radius decision. And the organization had been governing, like it was still 2019, review the app, approve the connector, hope the human remembered the policy. That model collapses the moment AI makes creation cheap. This is the part executives consistently miss. AI doesn't just accelerate output, it accelerates entropy. Because it lets more people build more automations with less friction, and it turns, I just need a quick summary into a data processing event that may cross boundaries you never tested. The estate becomes more probabilistic, not because the AI is evil, but because the number of states the system can enter explodes. So leadership faced a false choice: block AI and accept shadow AI, or enable AI and accept chaos. The control plane move was to reject the false choice. They reframed Copilot and agents as governable infrastructure, not as productivity features, not as optional experiments, as a new workload class that required the same treatment as any other production automation surface. Identity, policy, lifecycle, telemetry. And they stopped calling it AI governance because that language invites policy theater. They called it central agent governance, a control plane for agents. The success condition wasn't no risk. That's fantasy. The success condition was rapid rollout without losing control, clear ownership, enforced boundaries, observable behavior, a quarantine path when things go wrong, and an executive story grounded in operations, not hope. That sets up the next section. The control plane shift itself. Prompt-level DLP, agent identity, lifecycle controls, and monitoring that assumes defects are normal, not exceptional. Case study 3, control plane shift. Prompt, DLP, plus agent identity, plus monitoring. So they built the control plane the same way they rebuilt the others. They stopped arguing about individual copilots and started engineering the system that copilots must pass through. The first layer was prompt-level DLP because prompts are the new exfiltration format. Not files, not emails, prompts. They used Microsoft Purview DLP policies scoped specifically to Microsoft 365 Copilot and Copilot Chat with two enforcement paths: rules based on sensitive information types and rules based on sensitivity labels. And they treated those as separate controls because they are. Site-based rules catch the obvious stuff: credit cards, national IDs, the patents compliance teams already understand. Label-based rules catch the intentional classification of this document is off-limits for AI processing. But they didn't sell this as we turned on DLP. They sold it as AI processing is now a governed location, and we can block it the same way we block an email leaving the tenant. Then they did the part most organizations refuse to do. They tested enforcement across experiences, not because they don't trust Microsoft. Because defects happen at the seams. They validated what gets excluded in Office apps, what remains accessible in Copilot chat, and where labels behave inconsistently. When they found gaps, they didn't pretend they didn't exist. They documented compensating controls and built monitoring around the weak spots. That's the control plane mindset. Treat product boundaries as probabilistic until proven deterministic. The second layer was agent identity. They stopped treating agents like features and started treating them like principles. Every sanctioned Copilot, every Copilot Studio agent, every automation that could call tools got mapped to an identity object with an owner, a purpose, and a lifecycle boundary. If the organization couldn't answer who owns this agent, the agent didn't belong in production. And they applied least privilege like it was going to be audited tomorrow, because it would be. The key move here was separating can chat from can act. Chatting over grounded content is already risky when oversharing exists. Tool invocation multiplies that risk because it turns text into execution. So tool-capable agents only received the minimal set of permissions required for their tool belt, and those permissions were bounded to specific resources wherever the platform allowed it. No directory-wide reads because it might need it later. No global connector access because we're still experimenting. They also put conditional access back in the story, not as an afterthought, but as the way to constrain privileged and unmanaged pathways around agents. Where admin sessions happen, what devices can manage agent configurations, and how risky sign-ins get challenged before they can modify the control plane itself. Then they built lifecycle controls for agents because agent sprawl is just app sprawl with better branding. Every agent had to exist in a registry: name, owner, business purpose, data sources, tools, zones, and an expiry review date. Not because governance loves forms, but because inventory is the difference between an asset and a rumor. They implemented retirement and quarantine pathways. An agent that stopped being used or started behaving strangely didn't trigger a meeting. It triggered a state change. Disable tool calls, restrict scopes, remove it from the approved catalog, force re-attestation. Most orgs say we'll monitor it as a substitute for lifecycle. They made monitoring part of lifecycle, which brings us to the third layer, telemetry and detection. They built monitoring around behavior, not around policy existence. They watched for drift signals, new agents created outside the approved pathway, connectors added to agents that changed their data reach, prompt patterns that repeatedly hit DLP blocks, and high-risk tool usage spikes. And they treated that telemetry as governance input, not as security noise. This is where they got honest about AI. Assume defects happen. Assume enforcement is inconsistent. Assume a future update changes behavior. Therefore, build layered controls and a rapid containment mechanism. So when the platform fails a label check in one surface, the organization still has identity boundaries, least privilege scopes, tool restrictions, DLP on prompts, and monitoring that can detect abnormal patterns. That's not paranoia. That's architecture. And the final shift was cultural. They stopped selling safe AI. They sold governable AI. Safe implies zero failure. Governable implies observable failure with bounded blast radius and a fast response path. Executives understand that because it maps to every other system they already trust. Financial controls, change management, incident response. This control plane didn't make Copilot perfect. It made Copilot survivable at scale, and that's why the rollout didn't require heroics. It required design. Case study 3, outcomes, rollout speed without losing control. The outcomes in the Copilot case weren't measured in how excited people sounded in a town hall. They were measured in time, incidence, and adoption behavior, because that's where AI programs usually die. First, rollout speed. They went from, we're not sure if we should enable this, to a company-wide rollout in 90 days. Not a slow pilot that never graduates, not a limited preview that becomes permanent because nobody wants to own the decision. 90 days because the control plane made the risk legible and the path repeatable. That's what executives actually buy, not AI, but the ability to say yes without gambling the tenant. Second, sensitive data leakage events. They reported 0. And it's important to say what that does and doesn't mean. It doesn't mean Copilot never touched sensitive data. It doesn't mean every label was perfect. It doesn't mean the platform never misbehaved. We already know seams can fail. What it means is that the system didn't produce a confirmed incident where restricted data escaped its intended boundary through Copilot-enabled pathways. The layered controls did their job. Prompt DLP blocked obvious exfiltration formats. Label-based exclusions removed high-risk content from grounding, where supported. least privilege agent identities, limited blast radius when something did slip through, and monitoring gave them a detection story that didn't depend on luck. In other words, failure modes existed, but they were contained and observable. Third, adoption. Adoption landed at about 2.3 times the forecast. That sounds like a vanity metric until you translate it into what actually happened in the organization. People used the sanction tool because it was easier than routing around it. This is the piece most governance teams refuse to internalize. People don't bypass controls because they love risk. They bypass controls because the controlled path is slower, unclear, or humiliating. The moment the control plane made Copilot usage predictable, clear boundaries, clear no, clear exception paths, users stopped treating it as a trap. They treated it as infrastructure. And once that happens, adoption becomes an outcome of trust, not a marketing campaign. The more interesting outcome was operational posture. Before the control plane, every executive question turned into an argument. Is Copilot safe? Can we let people build their own agents? What happens if someone pastes customer data into a prompt? Those questions don't have one-time answers because the platform changes and human behavior changes. After the control plane, the questions became operational. Which agents exist? Which ones can act? Which data sources do they touch? Which DLP rules are firing? Which zones are being used? What's the quarantine path if we see drift? That shift matters because it turns AI governance from policy theater into systems management. It becomes boring. Boring is good. Now the constraint, the part that stops this from becoming a fairy tale, is maturity. Two maturities specifically. Labeling maturity. If sensitivity labels are inconsistent, then label-based DLP for Copilot is inconsistent. The control plane can't enforce a classification model you didn't implement, so they had to treat labeling as foundational infrastructure, not as a compliance project. They prioritized high-risk repositories first, automated where they could, and accepted that coverage would ramp over time. Identity hygiene maturity. If the tenant already tolerates overprivileged apps and orphaned principles, then adding agents is just adding gasoline. Their success depended on treating agent identities like first-class principles with ownership, review, and bounded permissions. So yes, the outcomes were strong, fast rollout, no confirmed sensitive leakage events, and adoption that beat forecasts. But the real win was simpler. They didn't make AI safe, they made AI governable. And that's the only goal that survives contact with reality, because the next platform update, the next defect, and the next clever user will always show up. The control plane is how you keep that from becoming panic. Executive objection. Governance slows innovation. This is the line that shows up in every executive meeting, usually right after someone describes a control that sounds like work. Governance slows innovation. It feels true because most organizations have only experienced governance as paperwork. Intake forms, review boards, exception emails, and a 2-week wait to be told no without an alternative. That's not governance, that's a queue with a badge. The uncomfortable truth is that governance doesn't slow innovation. Human review slows innovation. And when you confuse those two, you build the most expensive kind of theater. You keep the meetings, you keep the delays, and you still fail audits because none of it is enforceable. Here's what's actually happening in governance slows innovation organizations. The business wants to ship. It wants to reduce risk. Security wants proof. Compliance wants consistency. Nobody owns the system behavior that connects those goals. So they default to the only control they can operate without engineering, manual approval. Manual approval becomes the policy engine. That means the slowest thing in the system defines the throughput of the entire organization. It's not the platform, it's not Power Platform or Azure or Copilot. It's the fact that you decided humans would be the control plane. And that's why executives think governance is the enemy. They've only seen governance as humans blocking humans. Now flip the model. A control plane isn't a new committee. It's a programmable decision layer that makes the safe path the easy path. It takes intent, who can create what, where, with which data pathways, and turns it into enforced defaults. That is not slower, it's faster, because it removes negotiation from the hot path. The thing nobody says out loud is that app-first scaling is what slows innovation over time. It looks fast early because you can build anything anywhere. Then the estate grows, ownership decays, exceptions metastasize, and suddenly every new app needs a review because nobody trusts the system anymore. Innovation becomes gated by distrust. That's the cost of entropy. You pay it later as friction. Control planes do the opposite. They accelerate innovation by making self-service safe. Not safe because people are good. Safe because the system doesn't allow unsafe defaults in the zones that matter. This is the part executives actually care about, speed with repeatability. If a business unit can create an internal productivity app in 20 minutes because the environment is pre-classified, the connector set is already constrained, the ownership model is enforced, and the inventory is automatic, that is faster than a 6-week approval cycle. It's also more governable than the approval cycle because the approval cycle produces opinions. The control plane produces evidence. And yes, there are still constraints. That's the point. The question isn't whether constraints exist. The question is whether the constraints are enforced by design or enforced by humans after the fact, because enforcement after the fact is where innovation dies. Rework, retrofits, and emergency exceptions that become permanent. This is where the "but therefore" logic matters. Teams want speed, but manual governance creates queues. Therefore, teams root around governance. But rooting around governance creates shadow systems and audit gaps. Therefore, leadership reacts by adding more approvals. And now the organization has the worst of both worlds: slower delivery and less visibility. Control plane design breaks that loop. It creates two lanes on purpose: a green lane for exploration, where the blast radius is limited by design, and a red lane for regulated work, where unsafe pairings are impossible and evidence is automatic. The lanes aren't moral judgments, they're architectural boundaries. And when someone needs an exception, the exception is not an email thread. It's an engineered workflow with an owner and an expiry. Exceptions stop being political. They become governed objects. So the rebuttal to governance slows innovation isn't a motivational speech about balance. It's a system statement. Apps slow innovation. Control planes accelerate it. Because apps scale outputs, but they also scale ambiguity. Who owns what? Where the data goes? What changed? What's allowed? What's exempt? Ambiguity creates tickets. Tickets create queues. Queues create shadow IT. Shadow IT creates incidents. Incidents create more governance theater. That's the cycle you're in. The way out is to stop making humans the policy engine. If you want a line that lands in an executive room, it's this: if your governance depends on humans reviewing apps, you don't have governance. You have bottlenecks. A control plane makes governance disappear into the creation pathway. And when governance becomes invisible, innovation stops fighting it. It uses it. The new operating model: self-service with guardrails. So if control planes replace human review, the next question is obvious. What does the operating model look like when it's real? Not a slide, not a policy wiki, not a center of excellence that exists as a mailbox. An operating model that actually moves work through the tenant without turning every decision into a ticket. It starts with admitting a simple truth: self-service is going to happen. The only choice is whether it happens inside your boundaries or outside them. So the model becomes self-service with guardrails, not self-service with training, not self-service with "please follow the guidelines." Guardrails, enforced boundaries that shape behavior even when nobody is paying attention. The first mechanism is zoning. Green zones exist for exploration. Makers can build, test connectors, and prototype without waiting for a committee. But the green zone has intentionally limited blast radius, controlled sharing defaults, limited data access patterns, and a clear rule that green artifacts are not production dependencies. If they become valuable, they get promoted. Promotion is not moral judgment. Promotion is a controlled transition into a zone where the rules change. Yellow zones exist for departmental solutions. Real value, real users, but still bounded risk. Connector sets narrow. Sharing rules tighten. Ownership continuity becomes mandatory. This is where most internal productivity automation should live. Red zones exist for regulated workloads: HR, finance, customer data, anything with real compliance exposure. In red zones, the system stops pretending. Connector allow lists, strong identity controls, managed solution discipline, logging and evidence as defaults. You do not request permission to be safe. Safety is built into the zone, and exceptions become explicit objects with owners and expiry. This zoning model does something executives understand immediately. It replaces debates with lanes. Instead of asking, should we allow this, the question becomes, which lane does it belong in? And the answer determines what the platform will allow by default. Now, the moment you introduce zones, you trigger the second question: who runs them? This is where most orgs fall into the COE trap. They build a hub, centralize every decision, and recreate the same human bottleneck they claimed they were eliminating. So the operating model needs to be explicit: hub and spoke or federated, chosen on purpose. A hub and spoke model works when you need consistency and you can't staff 6 independent governance teams. The hub defines policy, patterns, templates, and the control plane automation. The spokes build solutions inside those constraints and escalate only when they need a new capability added to the catalog. A federated model works when scale forces it. Multiple business units run their own automation pods, but they share a common control plane contract. Same zoning definitions, same ownership requirements, same inventory fields, same exception workflow, same telemetry. Autonomy in the data plane, consistency in the control plane. And no, where somewhere in between is not a model, it's how drift becomes permanent. The third mechanism is engineered exception pathways. If exceptions live in email threads, your control plane isn't real. Your control plane is social dynamics. Exceptions have to be workflows: request, justification, scope, time-bound approval, auto-review, and auto-expiry. The goal isn't to eliminate exceptions. The goal is to eliminate invisible exceptions. Invisible exceptions are how conditional access becomes conditional chaos, how DLP becomes inconsistent, and how audits turn into scavenger hunts. The fourth mechanism is standard artifacts, templates that encode naming, tagging, ownership, and logging, solution packaging that enforces lifecycle, connector catalogs that define approved pathways, runbooks that describe what happens when a maker leaves, when a flow breaks, when an agent starts behaving strangely. This isn't bureaucracy. This is how you remove bureaucracy. Because when patterns are standardized, every new project doesn't invent governance from scratch. And then there's the incentive problem, which every control plane strategy ignores until the tenant collapses. If you reward app count, you will get app count. You will also get duplicates, abandoned utilities, and a support backlog that grows faster than your admin team. So the operating model has to reward the opposite: deprecation and reuse. Deprecation means you get credit for ending things cleanly. Reuse means you get credit for building components others can adopt. And those incentives can't just be cultural. They need system support, inventory visibility, reuse catalogs, and lifecycle automation that makes clean retirement the default behavior. Finally, the model needs one executive-facing truth serum, a single metric that measures whether guardrails are working or just being performed. That metric is support tickets, because ticket volume is where ambiguity cashes out. It's where missing ownership becomes cost, where policy inconsistency becomes friction, where exceptions become delays, where drift becomes outages. A control plane operating model isn't more governance, it's less drama. And it's achieved the only way drama ever dies in Microsoft estates, by making the system enforce intent at scale so humans don't have to. The metric, 40% reduction in governance-related support tickets. So if an executive asks, how do we know this control plane thing is real? The answer can't be because the admin center looks cleaner. It has to be a metric that punishes theater. Governance-related support tickets do that. Define the category brutally. Tickets about ownership transfers, broken connections, access requests, connector approvals, DLP confusion, environment drift, who can see this, why did this stop, and the classic, nobody knows what this flow does. Those aren't IT problems. They're control plane failures being paid for with human time. Ticket volume is the truth serum because it measures friction and ambiguity at the point it becomes labor. And labor is what executives actually fund, whether they admit it or not. Now, the number isn't mystical. 40% reduction comes from mechanics. Fewer unknown owners, fewer manual approval loops, fewer inconsistent DLP outcomes between zones, fewer emergency fixes when a leaver takes the only edit rights with them. The key is you don't chase the number, you instrument it. Baseline first. Tag tickets for 30 to 60 days with a simple taxonomy: ownership, access, connectors, DLP, environment, identity, lifecycle. Then roll out the control plane gates. Enforced creation pathways, continuity ownership, zoned policies, automated retirement signals, inventory that answers questions without meetings. Then you measure deltas, not overall ticket volume, because that's noisy. Governance-related volume, time to resolution, reopen rate, and escalation rate to admins, because admins being the hot path is the failure mode. When those curves bend, it's not a productivity story. It's proof that ambiguity stopped reproducing. Failure modes, how control planes rot into theater, 700 words. Control planes aren't immune to entropy. They just move the fight upstream. And if you build one badly, you don't get safety. You get a more expensive version of the same chaos, now with a nicer vocabulary. Here are the failure modes that rot a control plane into theater. First, overprivileged automation. The moment someone says, we'll just use app-only permissions so we can run this headless, the control plane is one bad consent grant away from becoming an attacker's dream. Graph makes it easy to automate at scale. That's the value. That's also the blast radius. If the control plane's provisioning engine has permissions that allow it to enumerate the directory, modify owners, create service principals, and grant access broadly, you've built a universal skeleton key. And then you'll tell auditors, don't worry, only the automation uses it. That sentence has never protected anyone. A control plane is supposed to enforce least privilege. If the control plane itself violates least privilege, you didn't engineer governance. You engineered a privileged backdoor with a runbook. Second, policy sprawl. Conditional access is the classic example because it looks like a policy engine and behaves like an additive rule set with no sense of your intent. The policies pile up, exclusions pile up, legacy exceptions never expire, and you eventually reach a state where nobody can explain why an access outcome happened. That is conditional chaos. And it's not limited to Entra. It happens in DLP. It happens in environment strategies. It happens in connector governance. Every time you keep adding rules without pruning, testing, and versioning, you convert a deterministic model into a probabilistic one. The control plane can't be set and forget. It has to be treated like code, testable, reviewable, and actively refactored. Otherwise, it becomes a museum of yesterday's incidents. Third, label fantasy. DLP for Copilot and agents is real, but it's only as strong as your labeling coverage and your enforcement consistency across experiences. If your sensitivity labels are an aspirational project, DLP becomes a false sense of control. If you assume a label blocks everywhere and it actually blocks in some Office apps but not in other Copilot scenarios, you have a gap. And the gap will get found, not by an attacker first, by an employee who just wants an answer and doesn't understand why the protected document still shows up in a chat scenario. Then it becomes a compliance escalation. Then the reaction is panic. Then leadership says AI is unsafe. Then shadow AI grows. A mature control plane doesn't pretend label coverage is complete. It treats coverage gaps as explicit risk and builds compensating controls. Least privilege, tool restrictions, zoning, monitoring, and containment. Fourth, orphaned everything. Control plane thinking usually starts with apps and flows, then it graduates to identities and subscriptions. And then AI shows up and you get a new scaling problem. The number of principles explodes. Agents, Copilot, service principles, managed identities, connectors, automation accounts, runtime tools. If you don't engineer lifecycle, ownership, continuity, retirement, quarantine, your control plane turns into a registry of ghosts. And ghosts don't just waste money. They retain permissions, retain data paths, and retain the ability to surprise you in an incident. Orphaning is not a cleanup task, it's a design failure. Every identity and automation object should have a lifecycle that ends by default. If it can persist without an owner and without activity, you didn't build a control plane, you built an artifact store. Fifth, no telemetry. This is the most common and the most embarrassing. Organizations build controls and then never prove they work. They don't measure drift. They don't measure bypass attempts. They don't measure how often DLP blocks happen. They don't measure whether exceptions expire. They don't measure whether inventory is accurate. They just assume. And in Microsoft ecosystems, assumption is where incidents come from. If you can't observe drift, you can't claim control. If you can't show evidence without heroics, your control plane is a slide deck. Telemetry is not nice to have. Telemetry is the control plane's nervous system. Without it, you're just enforcing rules blindly and calling it governance. And the final failure mode, the one that kills the whole model, is when the organization rebuilds human review inside the control plane. They build a portal, then they add approval steps, then they add exceptions, then they add a temporary manual override. And suddenly, admins are the hot path again. Tickets come back, queues come back, shadow systems come back. A control plane can include humans. For high-risk decisions, it should. But humans can't be the default decision engine. If your control plane requires a person to bless every creation, you didn't remove the bottleneck. You just rebranded it. The system law stays the same. At enterprise scale, the bottleneck is always the part that requires attention. So if you want this to work, the control plane has to do what humans can't. Enforce intent consistently, continuously, and without negotiation. That means least privilege baked into automation, policies treated like code, labels treated like coverage, not magic, lifecycle treated as default, telemetry treated as mandatory, and human review reserved for the few decisions that actually deserve it. Otherwise, you'll end up right where you started. More apps, more tickets, more governance, less control. Stop scaling apps. Scale a programmable control plane that makes governance invisible and innovation safe by default. If this episode helps you cut governance-related ticket volume and audit friction, leave a review so more people find it. And connect with Mirko Peters on LinkedIn. I post control plane patterns and the ugly lessons that create them. Next topic, what part of your tenant feels like conditional chaos right now?